Alright, believe it or not, this is my third try to make this perfect for you guys, because I like you guys. So, we're looking at a cylinder with a hemispherical ends. So I'm going to draw a picture. So here's my hemisphere, my cylinder first, sorry. There's my cylinder. And it has hemispherical ends. Round ends. Looks something like this. That looks awful. But, we get the idea. Now, we're being told that it is being deflated at a rate of 34 cubic centimeters per minute. Now, we've been talking about that. That's kind of like our given. They're telling us the change in volume. Now, it's being deflated, so it's going to be negative. So we can make that negative 34 pi centimeters cubed per minute. At the instant, the radius is 4 centimeters. So they even tell me the radius is 4 centimeters. Now, they also tell me the volume of the balloon. I don't know why. Maybe they were going to use that later on. 215 pi cubic centimeters. And the radius is decreasing at a rate of 1 cubic centimeter per minute. So they tell me how fast the radius is changing. Negative 1 centimeter per minute. So they gave me all this information. I'm going to write it down. And on the AP test, you know what? They're going to give you a point just for writing down all your givens right there. Now, part A is not really a calculus question, just more of an algebra one. It's asking us, at this instant, what's the height of the cylinder? So to write this out, to get the height of the cylinder, I need to use my volume. The problem is they only give me the total volume. They don't give me the volume of the cylinder. So when I write out my volume equation, it's really the volume total. And there's two parts to it. I'm going to have the volume of the cylinder. And I'm going to add that to the volume of the sphere. Now you might be saying, Mr. Werner, it's hemispheres. Yes, but there's two hemispheres, and two hemispheres make a whole sphere. There we go. Easy. So my volume formula, very easy, becomes V equals pi r squared h plus 4/3 pi r cubed. And I can just plug in everything. I know all this stuff. They tell me the volume. That's 215 pi equals pi. We know what the radius. They tell me the radius is 4. That becomes 16h plus 4/3 pi. We know what r is. It's 4. 4 cubed is 64. And I can use a little bit of algebra. Look, they all have pi in common. Well, I like to eat pi before and after the holidays, because before and after, it just cancels itself out. So when I write this now, I get 215 equals 16h plus, and I'm going to write this as a decimal because I like decimals sometimes. This is 4/3 times 64, and I get 85 1/3. 85.333. Therefore, solving for h, and I'm just going to do a little bit of algebra. I take that 215 minus 85.33333, and I divide that by 16. And I get 8.104. So I get 8.104 centimeters. And there's the height of our cylinder right there. Very easy to do. Now the next one's a calculus question. Now on the test or quiz, a question like this won't be worth much because it's just algebra. Maybe 2 points. Now at this instant, how fast is the height of the cylinder decreasing? Now we're talking calculus. Because it's asking me how fast the height of the cylinder is decreasing. It's asking me to find dH dt. So I'm going to write out my formula again. V equals pi r squared h plus 4/3 pi r cubed. You need to write this down again, even though we already have it, okay? Now, normally, we could replace r or h. But we're given a ratio, a similar triangle or something like that. But if you notice here we can't replace it. So we can't replace r or h. So we have to take the derivative, and yes, we have product rule here. There's my first, there's my second. So when I take the derivative, dv dt, we get the first, pi r squared, dh dt, plus the second, h times the derivative of the first, 2 pi r dr dt. And that's going, we get 4 pi r squared dr dt. And a lot of these I can replace. dv dt, we were told that. That's negative 34 pi equals pi. We know the radius is 4, so that's 16 dh dt. H, we just found h in part A. Part A, that was 8.104. 2 pi, we know the radius is 4. And dr dt we're told is -1, way up here. Plus 4 pi, again, 16. And again, dr dt, -1. Now, I'm going to clean all of this up because that looks ugly. But again, if you notice, they all have pi in common, and they'll cancel out. So I'm going to get this -34 equals 16 dh dt. And I'm going to write this out. Oh, that's just, let's see. I'm just going to write this, simplify this real quickly here on my calculator. That becomes, give me a second here. What's that? 8.104 times 2 times 4, and I get 64.832, and it will be negative because of -1. So I go minus 64.832, and this becomes, again, over here, minus 64. And doing a little bit of algebra, dh dt, if you solve it, we get this -34 plus 64.832 plus 64, and I divide that by 16. And I get 5.927. 5.927 units. H is centimeters, time is in minutes. And there's our answer. So we would say the height is decreasing at a rate of 5.927 centimeters per minute. So make sure you have this down for your notes. I will be looking for these during your test. Okay? Bye.